The first part of this video is going to be briefly reviewing on how to plot polar coordinates. However, I will say if you would like a little bit more than a brief review, you can go to my YouTube channel and see other videos that go through this in a little bit more detail. So YouTube channel, and if you go to my Calculus 2 playlist, then you'll see all these videos, polar coordinates, polar graphs. Those are the more detailed videos on what we will be reviewing today. So how do you plot polar coordinates? Well, first of all, you use r and theta, where r is a directed distance and theta is your directed angle. And we usually take it from the polar axis right here, this green arrow. So we measure everything from there, just like in trigonometry. Instead of the origin, we now call it the pole. So how would we plot the point 5 pi over 3? Well, believe it or not, you really should do theta first. It just makes it easier. Right? So I need to find where pi over 3 is, or 60 degrees. So this is 0, this is pi over 2, and each of these lines are every 15 degrees. So I know that this is pi over 6 for 30 degrees, pi over 4 for 45 degrees, and pi over 3 for 60 degrees. So you can see my red line that I've already put in there. That gives you pi over 3. And for 5, you would go out 1, 2, 3, 4, 5. And so that would be point A. Now that's great. But point A has an infinite amount of names. So let's just practice that. What if I wanted to keep it as 5, but I wanted a negative angle? Try to review from trig. How can I go this way? How far would that be? Well, it would be pi over 3 minus 2 pi, which is negative 5 pi over 3. So this angle could be pi over 3 or negative 5 pi over 3. It can also has an infinite amount of other angles just going around the circle either clockwise or counterclockwise an infinite amount of times. So that's a second name for A. But what if I wanted a negative value for my radius? That's what most students really get confused about. So negative radius, you have to think about a direction going backwards. So let's just highlight this line right here. Okay, so that line is represented by a positive pi over 3 and a negative 5 pi over 3. So if I was standing at the pole and looking toward those two angles, I would be walking out in a positive direction. But what if I am facing that direction? What would those angles be? Well, it's a line, so it's 180 degrees or pi. So if I take pi over 3 and I add pi, I'm going to get 4 pi over 3. And then negative, again, I would say 4 pi over 3 minus 2 pi, and that would be negative 2 pi over 3. So this line is pointing toward those two angles. And again, infinite amount of angles, just one positive and one negative. So what if I'm facing toward those angles, but I am walking backwards? 1, 2, 3, 4, 5. That's what I want. So I want negative 5, but I would have 4 pi over 3. I could also have negative 5 and negative 2 pi over 3. So one good way to check your work is those two angles, take the absolute value of them, add them together, it's 2 pi all the way around the circle. Same thing here and here. Let's look at some special graphs and how to use our graphing calculator to get them. Well, First of all, in a TI-83 or 84 or 84 plus, your mode is polar, and then you can choose degrees or radians. Most students like degrees just because they do. Okay, so we need to make sure that window corresponds to how you're choosing it. But circles are easy. Radius is 3. So you just go out 1, 2, 3. Now, as you recall, a circle is not a function, but in polar mode, it is. So we also have circles that are not centered at the origin. We have circles that can go to the left or to the right of the pole. And since they're going to be symmetric with respect to what we would call the x-axis, although in polar mode that really doesn't exist, but if you superimpose the x and y coordinate system over your polar, that would be x. Right? If you look at this, 2 is your diameter. That would be negative 2 cosine theta, where this would be positive 2 cosine theta. Sine also gives you circles. That would be your diameter. 1, 2, 3, 4, 5, 6. Okay, and if it's positive, again, remember sine is symmetric with respect to your y-axis. And again, if we superimpose that, that would be, of course, your y-axis. And so sine circles positive are going to be in the top part, negative, my best circle there. Okay, so let's just practice how to graph these things on the graphing calculator, just to make sure we understand. So the first thing I'm going to do is I'm going to go to mode, and I'm going to go ahead and put it in degree mode. And I also want it to be in polar mode. So now when I go to y equals, you can see you have r's. So I'm going to clear that. And so the first one I'm going to do is 3 plus 3 cosine theta. 3 plus 3 cosine. And when you do your variable key, it's going to default to theta because you're in polar mode. Now, I need to check my window since I use degrees. That's not going to help me. I want to go from 0 to 360 degrees at the minimum. And I could do every 1 degree. That's going to take a while, so I think I'll do every 10. And then I think I'll just go from negative 8 to positive 8, and negative 8 to positive 8. And now I'm going to hit graph. See what I get. I'm thinking y'all said, no, you didn't hit something. So let's see. I did, oh, look at there. My maximum for my x value needs to be positive 8. Now let's look at that graph. Okay, so we have this heart-shaped looking thing. It's symmetric with respect to the x-axis, which you should expect because it's cosine. If you look from here to here, there's a distance of 3. That's 3. And all the way across is 6. And yes, that has something to do with those numbers. Okay, so let's see what happens when we do 3 plus 4 sine theta. Okay, if you zoom in just a little bit, I want you to see, do you see that loop there? So we get this thing that kind of has a looped thing and kind of comes around. Not my best picture, but it's symmetric with respect to the y-axis because of sine. This distance right here is 1. From here to here is 3. And then from the top up to here, I believe, is 7. And again, it's because of those numbers. Right, so what happens when we subtract? So sine, I'm thinking symmetric with respect to the y-axis. So we have 5 minus 3 sine theta. Okay, that looks really fat, kind of comes around, still symmetric with respect to the y-axis because of that sine, and looks like kind of right in the middle from here to here, that might be 5, and I bet here to here is going to be 8. But again, we'll do some investigating. I just want you to be sure of how do you use your calculator. It needs to be either radian or degree mode, polar. If you're in degree mode, then theta needs to go at minimum 0 to 360. You can always do option 6 just to get you a standard window. We also have some things called limicons, right? And so those things can give you loops. They can be the same, so you kind of get this heart-shaped figure. In fact, that's called a cardioid. You can, so this number is smaller than that number, you're going to get a loop. If they're the same, you're going to get a cardioid. And if this is bigger than that, you're going to get kind of like this, I don't know, some people call it bean-shaped. It doesn't quite make it into the pole. It's a little bit flatter. Okay? But the cosine and the sine gives you that symmetry. You really should take a minute and view that YouTube video. It's really kind of cool to show you how those get traced out. Now, a lemniscate is a figure 8. It's a little bit harder to graph on a graphing calculator because it's r squared. And so if you just memorize it, it's a little bit easier. The good news is they only look like two things. If it's cosine, then you're on symmetric with respect to the x-axis. You take the square root of that number, and that's how big it is. Okay? If it's sine, it's always symmetric with respect to the 45-degree angle, or pi over 4. And again, you take the square root of that number, and that's how far you go out. Also, you can get some rose curves. Another really good video, not by me, to show you how they indeed get traced out and how you get petals and things like that. Okay? But cosine is symmetric with respect to the x-axis. Sine is going to be symmetric with respect to the y-axis. And number of petals and all of that good stuff, again, can be viewed on my previous videos. What we're going to be interested in for here is when does it pass through the pole? Okay? When does r equal to 0? Okay, so let's look at this one. When does r equal to 0? So if I have 0 equals 3 cosine of 3 theta. So if I divide by 3, I get 0. So I'm saying, when does the cosine of 3 theta equals to 0? This is where you have to be really careful because of the 3 theta. So 3 theta is the inverse cosine of 0. Well, we know cosine equals to 0, do we know? At pi over 2 and 3 pi over 2. But that's if you go from 0 to 2 pi. That 3 theta says, do that 3 more times. Go around the circle 3 times. So I don't want to go from 0 to 2 pi. I want to go 0 to 6 pi. All right? So I have a lot more angles. So I just add 2 pi. So I'm going to get 5 pi over 2. Add 2 pi. Okay, so that's the second time around the circle. Then the third time, add 2 pi again. Add 2 pi again. And then, that's 3 theta. Now I have to divide everything by 3. So what's going to happen is all of those denominators, I'm going to divide by 3, become 6. And yes, you could reduce them. So I have theta, when does r equal to 0? At pi over 6. Well, guess what? This is pi over 6. Goes through the pole. Okay, 3 pi over 6, I believe that's the same as pi over 2. That's right there. Goes through the pole again. 5 pi over 6. You know, I wrote 3, I'm in a 6. Okay, so 5 pi over 6. Where's that? That's over here, 5 pi over 6, and this was pi over 2. Okay. What was the next one? We have 7 pi over 6. Guess what? That's this line. And then we have 9 pi over 6. That's 3 pi over 2. Already got that one in. So hopefully you're kind of guessing what the next one is. So we have 11 pi over 6. And that is right here. So do you have to list all of them? No, to be safe. Yes, but it actually went through the pole 6 times as it was tracing out this curve. And that's why I really want you to see this video so you can kind of see how it is traced out. Right? So as it went around, it went through the pole once, twice, 3 times, and if you kept tracing, it would go through it 3 more, an infinite amount of times. So those would be the correct answer. So again, a little bit of review of your trigonometry. Remember, when you have bigger than theta, you've got to go around the circle many more times.